maybe that would lead to complications.
I'll try to throw it from the beginning of here.
Yeah.
Just so it's easier for measurement.
Yeah, and not too high. Ooh. Nice, okay.
We can also do a slow motion.
Like in real life? Or?
Why are we throwing hailstones at a solar panel? More on that later. I'm Tim from Biosphere Solar, and we're developing the world's first circular and fair solar panel. As you may know, solar is booming. Nearly 60% of solar installed worldwide is utility scale solar. The best way to deploy that at that scale is with big solar farms. For this approach, the protagonist of the solar boom, crystalline silicon, has been optimized for decades now. It has been estimated to cover up to 95% of the installed capacity as of now. Riding the waves of semiconductor technology in the late 20th century, crystalline silicon was the successor. It was the most effective tool towards mainstream adoption of solar energy. But we've seen that solar will be everywhere, on our boats, our clothing, and our houses. Solar can become a closer part of our lives, since it can be implemented onto any surface with an energy source that is present every single day, the sun. This means there will be no one-size-fits-all for these applications. So maybe, to make solar deployment happen everywhere to suit everyone's needs, it should be easy to build, design, and install our own kind of solar panel. With the Biosphere Solar team and our global contributors, we are developing a truly sustainable panel. We believe that we should be transparent about how we make, source, and earn from these solar panels. Now, what does that roadmap look like to get to market? Well, it has to be tested thoroughly through a certification body. This ensures the quality and the safety of the panel, and that all panels can be installed in the same way. Elias Garcia Goma from Solar Chills, a consultant for testing solar panels, has helped pave the road towards certification with us by giving us support.
Solar Chills is a company that helps organizations in testing solar panels. So in that sense, Solar Chills help new laboratories into setting up the equipment, setting up the test protocols. The challenges that companies face when they go to certification, they can change a lot. So we're talking here about a company that wants to make innovative solar panels. So in this case, a highly recyclable solar panel, which means will mean having a very different bill of material. So you will want to use a glass that is more easy to recycle, cells that are made with silicon that is slavery-free, which is quite rare to find, a backsheet that is not damaging the environment, etc. This means a whole combination of materials that are different from the standard materials used by most of the manufacturers. This means that when you need to go to the strict tests, like environmental chamber tests, where you bring the solar panel to 90 degrees hot, then to minus 40 degrees cold, at a very high humidity, and you repeat the cycle 20, 30, 50 times, there is a high chance that the very first combination of materials that you try will fail. The fact that you will have to test over and over and over, while at the same time, because you are, let's say, a new company, you might not have the facilities to test to perform such tests in-house as much as possible. So I would say that that is the main challenge.
To be fair, it's a good thing that we have experts. But the more specific and expensive a technology gets, the smaller the group of people who understand it. This becomes problematic when the world is becoming more and more reliant on technologies that this shrinking group of people actually understand. This might not be a huge day-to-day issue within borders, but between countries it can lead to disparities. Countries become slaves to the intellectual capital of other countries. That is why we look towards open source. The hypothesis around DIY and open source is that it enables sustainable innovation inherently. But this is a theory. Our co-founder Perrine is currently finishing her thesis on how open source hardware is perceived globally and how it can aid the energy transition. So let's ask her.
Open source hardware is essentially the design of hardware products in a way where anyone can openly find the designs, contribute to the design, copy them, and build on top of them. One of the key advantages to using open source hardware in the solar industry for testing specifically is that it would really lower the barriers to entry for startups or for tinkers who want to make their own solar panel and want to test their own solar panel. And the way that successful businesses, open source hardware businesses so far have succeeded in the market is by really focusing on what they're good at, so on what their specific USPs are, unique selling points. And then some companies have also adopted a model in which they completely open up their IP, but prevent other competitors from selling the products that they sell. And so from that you really see that open source hardware can also be quite a spectrum. And in this transition to open source hardware, it might be necessary to use this spectrum wisely.
Now back to the testing. Biosphere has already assessed that about half of the tests can be done in-house at a much lower cost than with a certification body. For example, instead of the hail test being done in a sophisticated lab with a projectile launcher in a high-tech environment, you can throw them at a solar panel, film them, analyze the footage using free software. And we currently have new team members who are working on smart ways to do what is called pre-compliance testing.
Hi, I'm Keshav, and I'm the new product and test engineer for Biosphere Solar.
Hi, I'm Mirjam. I'm the new product and test designer, and I'll be working closely together with Keshav and with Tim to get our solar panel through certification.
Hi, I'm Mihir. I'm from India. I'm currently doing my master's thesis at Biosphere Solar. My topic is on designing modular interconnections for disassemblable PV modules. At the moment, it is very difficult to disconnect the solar cells when they're connected by soldering. So my job is to find a way to interconnect them in such a way that you can disconnect them later on.
So I'm going to be working on, with Tim, the head of product development, to develop more in-house testing methods for our solar panels for things such as rigidity or efficiency or weather resistance in a way that can be done cheaper than official certification methods.
What's so incredibly exciting for me is that I've learned so many things about circular economy, about circular design throughout my studies at Delft University. And now I have the chance to actually make it work, to start testing, to develop it, and to see it come to life.
I'm really excited about working with solar cells and just going from an unfinished product to something that can actually generate energy. And while I'm testing them, I'll also learn about how to make them more durable.
I think the most important thing we'll be working on is how to make it repairable for people without specialized knowledge, without the need for incredibly specialized tools. Of course, it will need some degree of tools, but I find it very important that we design a panel that can be repaired by the local community and not by an industrial partner somewhere in the world. Because for our economy, it's so important that we get more local. We empower ourselves, we empower our communities, and that way we not only address the sustainability issues, we address the societal issues as well.
Additionally, we get help from contributors worldwide who have developed specific testing methods in a very low-cost way, such as Chris, who developed an IV curve tracer used to measure the performance of solar panels.
My name is Chris Satterley, and I designed a device that's used to measure and graph the power output of solar panels. This kind of instrument is called an IV curve tracer, and my design is called the IV Swinger. Commercial IV curve tracers are very expensive, and from the beginning I wanted to put my design in the public domain as open source hardware and software so there could be a more affordable option. My original intention was that IV Swinger would be strictly an educational tool, but it certainly can and has been used for testing and diagnosing the performance of PV modules in the field. All the hardware and software design files are freely available on GitHub, and there are step-by-step build instructions on the Instructables site. Several hundred IV Swingers have been built, and what I hadn't expected was how global the reach would be. IV Swingers have been built in countries such as Algeria, Malaysia, India, Chile, and many more.
We also get help from our mentor Joshua Pierce from Western University. He is a big proponent of using the power of open source hardware to advance the energy transition in his own research.
Hi, my name is Joshua Pierce, and I'm the director of the Free Appropriate Sustainable Technology Lab, or FAST Lab, here at Western University. We study open source appropriate technologies, where we take the innovation that drives open source software and hardware to appropriate technologies that are appropriate for people no matter where they live, for the context that they live in. We specifically focus on two types of appropriate technologies: solar photovoltaics that convert sunlight directly into electricity, and open source hardware developed mostly by 3D printers. And so the idea is, if you have an open source 3D printer that's powered with solar photovoltaics, you can manufacture pretty much any device or product that you need for yourself using local materials, oftentimes recycled materials in the location where you live. It's already well established that the use of open source developmental methodologies are the fastest way to drive innovation in the technology sphere. It was proven first in software, and now we're doing it really well in hardware. Where it gets really exciting is when we start to apply it to global problems, because the beauty of open source is you have people from all over the world collaborating together to just destroy problems. Our greatest problem right now is the energy transition. We need to completely eliminate the use of fossil fuels for electricity generation, heating, and transportation, and we can do that by applying open source developmental methods to energy technologies. Of all the different types of renewable energy, solar photovoltaics, which converts sunlight directly into electricity, is the most promising by far. In order to drive the development of photovoltaic technology even faster, we're applying open source technologies to it so that we have mass collaboration throughout the globe in order to push the technologies to the next level. Proprietary technology development does work, but if you look at the PV industry right now, many of the technologies that an individual company will apply to their particular product, whether it's an inverter or a photovoltaic module, are only applied to that module, and it leaves the rest of the industry out. By using an open source method, however, we can take the best ideas from everybody and combine them all together, so we not only get superior performance, but we also get lower costs and a faster energy transition.
Open source makes technology more accessible, making it more fair. It acknowledges that the purpose of the solar industry is solving global climate change. It's beyond business. To keep up to date with Biosphere, make sure to check out our Wikifactory page, LinkedIn page, and don't forget to hit that like and subscribe button so that we can share our message and our tech with the world.